I'm here to give you a talk today in regards to technology, which has been something I've been very, very interested in for many, many years. I think, technology is something that's amorphous and we need to put some definition around it. So today I hope to walk you through some technology advances and see how they apply to timber. So let's just go here. Right, so technology has many, many definitions and forms, but it comes from a scientific knowledge, practical purposes that are applied to that, machinery and equipment, but more importantly, it's a branch of knowledge. So technology doesn't have to be around capital equipment, producing something. It can be ideation, it can be novelty, it can be experimentation. And so all of these things coalesce to give you the overall arching band of technology. But when we think about timber and technology, is this what we're really talking about? As beautiful as it is some technology and it does involve timber, but not necessarily. Or is it something like this, which is holding technology rather than being technology itself? Or is it something more like this? And this is sort of the advances that we're talking about moving forward. But before we move into technology, we need to just give an overview of the types of technology that are available and what are we talking about when it relates to construction. First and foremost, we've got the third industrial revolution, which is the one which includes computers, etc. And then now we're looking at the fourth industrial revolution, which is really the interconnectedness of technology, smart devices, computing, real-time data, etc. And we've probably heard a lot about these sorts of terminologies, but we probably don't know how it applies. So I'm hoping to give you a bit of a glimpse into that today. Of course, integrated with technology is the Internet of Things, which is around that connectivity element. And so whilst you might have disparate parts of technology available in society, it's really around the interconnectedness of these two things to try and drive a new way or a new fashion of working. So we've got drones, we've got 3D, 4D printing, we've got companies of the future, we've got blockchain, we've got smart technology. I'm going to take you through some of these. My last talk I did site surveying and drones, not going to talk about that today. We are going to talk about things like the DNA of trees and how we can use that from a chain of custody perspective. We're going to talk about smart cities, and whilst the Toronto Sidewalk Labs project has somewhat dissipated in recent times, there is a PMX design and there's some great design tools that have come out of that that can give us a way of looking at buildings in a different fashion to provide different outcomes. And then again, you've got CAD services and design services that envelop. And then there's skill shortage as well. So we're looking at robotics and assembly elements. So blockchain. We've heard a lot about blockchain. You know it's related to Bitcoin. You probably may be familiar with the way it works, or you may not be familiar with the way it works. But essentially, it's looking at peer-to-peer technology. And if you would think of peer-to-peer technology as being as simple as sharing a file, commonly peer-to-peer technology was enveloped in a lot of debate around sharing movies, etc., and illegally pirating music, etc. So it's a similar sort of technology where we're using computers that are in individual isolated locations to exchange information to create a chain effectively. We won't go into it much more than that, but it's on the screen and I believe the video is being recorded, so if you do get access you can read all the words, etc. But how does it work in terms of a contract? So we talk about smart contracts here. So we've got the principal or owner right down to the contractor and the fabricator. And at each stage, you have this capacity to have a contract relationship between any element in the value chain. And then if we push that into a blockchain scenario, what you're effectively talking about at the very bottom there is trust. It's about building trust. If you were on the Prefab Oz webinar yesterday, Philip Greenham, who was from Minter Ellison, the ex-Minter Ellison, talked about blockchain in contracts. He's written contracts for 20 years and for 10 years been working in the modular or prefabricated space. He hasn't seen blockchain come into the contract world yet. However, I do know from speaking to some incubator hub people that are actually got venture capital together. They're working on these smart contracts and they're making them work so that we can actually put this trust or level of trust into the contracts. So watch this space when it comes to looking at smart contracts. And here's how it might interface. So, financing the project between the funding agent and the principal or the owner. It might be to do with the design of the steel where BIM would integrate. You've got drawings and specifications, so they hold some integrity. You've got procurement and title transfer, etc. And so this trust element of knowing you're going to get paid for the delivery of materials that may sit off-site at the moment, whether that be in, a CLT manufacturer's plant ready to be shipped to site and then assembled. This trust element of title transfer is one of the reasons why I think that there's very adversarial relationships with contracting in Australia, at least, and I'm sure other parts of the world. So blockchain's seen as a utility or an antidote to mistrust. The trust is really important, and if you know a lot about chain of custody when it comes to illegal logging, we know we've got FSC, we know we've got PFC. A lot of it's self-declaration, a lot of it's through an audit, and an audit can at times miss. However, Kevin Hill, who's based in Singapore, works with a group over there distributing KLH CLT panels into the region and does a lot of work in the islands doing resort work. He was part of a program that has been developed, which is called Double Helix. Double Helix seeks to do a DNA analysis on trees, provide a barcode for that tree, and then able to use stable isotopes and the wood anatomy to trace the chain of custody or the location from which timber came. Now, if that has come from an illegal source, a region that doesn't necessarily have a harvesting certificate or a sustainability certificate, this particular double helix process can weed out where the troubled areas are and can provide an evidence space for illegal harvesting of timber. This is the sort of services they offer. So there's a supply chain engagement, there's risk mitigation, there's ongoing verification, there's step-by-step and evidence reporting. And if you've got, or if you are familiar with, or you have PEFC certification, you'll know that there's actually a due diligence system in the certification system that provides that you must have evidence, you must do a risk assessment. So Double Helix fits into that portal, and I believe that Double Helix has been working with PEFC. And you'll actually see down there on the bottom right of the screen, nature's barcode, and you'll see there's a thumbprint there. So similar to human DNA, the tree has a DNA and you can effectively track it. How does that work in pragmatic sense? Well, say, for example, you've got some people that want to fund a project. They go to a project team. They say, please build this product. Product team fails to build that product. Then the money gets put back to the supporters or the purchasers of whatever goods or services is that they're looking at. So in essence, if we were to link this to blockchain and using double helix technology, if we're building a bridge of trust between the supply partners in a supply chain, then if there is an error or there's an omission or there isn't specific performance of the contract, then the financial elements do not pass to that party and you actually have a preventative stopgap effectively in the supply chain. So it can be quite useful from a technology perspective. Very infantile at the moment, but certainly is coming, and I think certainly will form part of more contracts moving forward in time. Prefabrication technology. So what we've been talking about up until now has been trust. What we need to talk about in this next section is about building. So if we're building trust through contracting and we're looking at what are the elements we're going to use to be able to provide a better building, then this particular page shows what we've called, colloquially in terms here in Australia, is a kit of parts. So it's essentially you've got residential floor cassettes, you've got kitchen cupboards, you've got stair systems, you've got balconies, you've got roof panels, you've got bathroom pods, etc., etc., etc. You've got column and bracing, you've got shear walls, you've got living spaces as well that just effectively fit into a model that you create. And so you can use this kit of parts to create a building. You're very, very pleased to know that a lot of this is in timber, which is the reason it's connected to this particular talk. And here's an example of that kit of parts coming together. So here we see a typical floor cassette, put in the services, put in some hydraulic heating, put in some insulation, wrap it with a bit of fire check, put in a timber floor on top of it, and you can essentially create a building from this kit of parts. And essentially it's just modules upon modules, and it gives you the capacity to build floor upon floor. And as long as you program this correctly and you sequence it correctly, you can create a building from the kit of parts. I'll move on now because time is short. If you're looking at the structure itself, there's several concepts here. So this is the PMX system that was developed with Michael Green. Sidewalk Labs is the proponent of this particular system. So you'll see here a steel pinwheel, you've got a concrete core, you've got a timber core, and you've got a timber exoskeleton. The timber exoskeleton has become the one that's most prominent in use at the moment, and we've got an example of that coming up. But in essence here we're saying that where you might have steel or concrete, you can equally build with timber, and the exoskeleton approach seems to be the one that's got the most weight at the moment. What does it look like? Well, this is what it looks like. So if you were to take some parametric modeling and some generative design and mix it with BIM, then you might come up with a concept like this. So essentially you've got an exoskeleton and glulam, and you've got some concrete floors, and timber floors on a concrete podium. If you look at things like dampening from a resistance perspective, you have this capacity to model these things in technology, which are fantastic now, and you can see that the one on the right performs much better than the one on the left, and that's because it has dampening technology sitting up in that roof area. And then you can have a myriad of facades that wrap around it, so triangulated, diamond, etc. You color it, you can do whatever you want. So the skin now becomes the customized element where the exoskeleton and the floor-to-floor system becomes quite common. And so from a design perspective and a manufacturing perspective, having common elements and going through your building structure is quite an advantage from a cost and time and speed advantage. And where you can be decorative or be creative is actually in your facade area, and you can have some unique designs that tie into the exoskeleton and the structure proper. And here's the sort of exploded version of it. So, you know, we've all seen the Toyota car that's exploded. This is the same thing from a building concept. I'm not going to go through this other than to say all the elements coalesce into a building structure, and you're able to produce something that is commensurate with a concrete or steel building using this type of technology or process. And if you're looking at just using the CLT and walls and floors in a what we call a waffle system, a honeycomb system, you'll see that they're quite small compartments and little models at the bottom, which is the 1, 2, 3, 4, 5, and 6. I would advise thinking very, very carefully around how you put those castellated joints on the bottom of the wall, because they can take an inordinate amount of time on the CNC. And if my old boss Gary Caulfield's on the line, he'll probably attest to that. And he can probably give you the figures off the top of his head of what it costs an hour to machine those on a CNC. So some technology and systems are great in theory. In practice, though, they can cost you a hell of a lot of time in processing. If you combine an exoskeleton with CLT floors, and then you have your facade systems, and you might have concrete cores, and you might have concrete stair systems, then you can get this hybrid type building. And hybridization of materials is becoming more prominent. We've always had the mantra, you know, certainly in Australia, for those international guests, that use the best material in the right location for the right purpose. And this is certainly a function of what's happening in the world at the moment when it comes to looking at hybridization of materials. And the most prominent example at the moment is the Treat Tower. So this is in Norway. You can see here that you've got an exoskeleton that has got a cladding system on the outside. If you look at the far left photo and you have a look at the base of the building, you'll actually see some what look to be like site huts or little units. They are actually the modules that slide into the exoskeleton. So they used a volumetric approach with an exoskeleton, popped in the modules and continued up with the exoskeleton, and then went on with the cladding or the facade. And here's what it looks like when it was completed. And it's as cold as I would imagine it would be in Melbourne in winter, certainly without the snow. But what a beautiful site from a beautiful building that stands as a beacon on this peninsula, using timber as the primary technology for the whole build. Software. I'm always banging on about software, and I'm not paid by any software providers, and I don't promote any software per se, but what I do have in mind is to show you what the technology is doing, and that's the basis upon which I'm showing you this information. So Autodesk is quite a large group and has quite a large suite of software underneath it. Revit is famously under the Autodesk suite. And so HSB CAD is the timber derivative or add-on module, which is now associated with as either a standalone project software or can be integrated with Revit. And you can do your post and beam design, your stick frame designing and your CLT design in HSB CAD. What's more importantly is that you can do it on Revit. So if you do modeling in Revit and you're able to use HSB CAD to effectively draw out those outputs and then put them through into a processing file, which effectively gives you a fairly accurate digital fabrication. So from design right through to CAD, so you can assess your shop drawings, through to CAM, which effectively activates the machines as it is in this image here, and provides the control for, you know, the Hundegger or the Wyman or whatever CNC or other device you're using to actually fabricate your timber. Why is this important? Well, because HSB Share has been around for a little while. It was launched as being on Revit probably about 2 years ago. It's starting to get some great advances, and it has the capacity to link in with these other technologies, including Azure, Forge, XBIM, etc., Unity. And so you can also hook up your HoloLens to it and do walkthroughs and fly-throughs using HSB CAD on Revit. So this is an ecosphere of technology rather than a standalone product, and that's why it's important to acknowledge it as being an advance in technology. How does it link? You've got your typical IFC files, which most people use when they don't have a direct portal from one program to another. So your 3D imagery comes through. This is cloud-based in this particular example. HSB Share shares that. It draws across all the metadata, including mapping as much of the properties of each element within each panel or each object that you create. However, I do believe that there are still some mapping issues, and you may have to go in and manually change some of the property naming protocols to be able to link in correctly. Then you have logical links to PDF, XLS, documents, JPEG, and this repository in the cloud provides you with sufficient space to be able to use an ecosphere of technology to be able to design what you need. And as I said, it'll go from design through to CAD, through to CAM, which is quite important. Of course, what else it does is it gives you QR codes for each of your elements, so you can use your mobile phone. Zap on the QR code, it should tell you that's panel 1, floor 2, west wing, number 6, and you should be able to locate that in virtual space using your HoloLens or even just a traditional 2D drawing, and locate where that panel's got to go for ease of installation. It also provides you with elements from a logistics perspective. So it gives you the loads, it gives you the sequencing of the panels for craning off and then putting onto site. And of course, this is vital for hook time and it's vital for sequencing, and it's vital for delivery. So it's quite an advanced ecosphere, and I've been banging on about it for a couple of years now. I'm hoping that it's becoming more prominent. I see HSB share and HSB CAD as being something that might move timber into a mass adoption part of the architecture and engineering world. And so that's why I think it's really important to acknowledge it. Global. So Global is the other side of the design parameters. It's specifically used by engineers for structural analysis and for design. And there's some specific protocols in here. So they're now putting in standards from all over the world, include, I believe, they put some Australian standards in now as well. So you can buy your bolt-on or your add-on to the program. And what's really great about this is you can get visual representations of this is, I think, your deformations, so you can actually see where you've got stress points, etc. But what's really important is that you can actually interchange this now with Revit. So if you take your Revit model in, you can then go and do your analysis, and then you're able to sort of have this interoperability between the two. And it's becoming quite a major talking point from a design perspective for prefabrication, because it really, you don't have one technology that can do everything end to end. However, with a number of technologies having this interoperability capacity, you are starting to get an ecosphere of technologies. But yes, you do have to pay the licensing fees for each technology, which can be costly. Transformation through design. So here is a project that my good friend Franco Piva from Ergodomus in Italy just recently completed using Global, and he's got here his BIM model. I'm just going to run through the sequence, and essentially he's able to design the building, and here it is in its real life form. And as it was in the BIM or the model, he was able to create the building, and it was erected and constructed exactly the way it was designed. And then you've got your finished product, and here they are side by side. So you can see that the design model and the actual building outcomes are effectively replicates. You will notice that there is a change in the window design at some point. So at some point someone said, well, let's make that architectural window pop in rather than a square one. But in essence, it is designed as it was intended, and it was built as it was intended to be designed. Connection technology. So we talk a lot about technology from a design perspective, prefabrication from a structural perspective, but what's actually changing at the moment is connection technology for timber. So when Rothoblast put out the X1, it was actually a game changer in terms of thoughts and an ideology and novelty around connections. I'm not sure how practical it is. I've not necessarily seen anyone that's used it other than some showpieces, but it's certainly a beautiful piece of hardware and certainly makes a beautiful aesthetic when it looks to joints and panels together. Well, they're using CAD or computer designing to be able to provide intelligence around the way that fixings need to go into timber, so it gets a maximum capacity on the connection. So this CAD element is coming into connections. And more importantly, you know, if you seal it up correctly and you put it in place, you can see that from a pragmatic perspective, it also works. And you now have an evolution of things like pitzels, which are now coming into play, where you've got concealed fixings effectively rebaited into the ends of timber, and you're able to put these screws in. There's a specific number of screws, a specific capacity loading for the pitzels, and you slide one element into another. It doesn't have any exposed fixings in any way, shape or form, and pitzels are becoming quite popular at the moment, which is really, really good. 3D and 4D printing developments, and this does bridge on connections. So here we see some 3D printed connections. So we can see that this is probably more a decorative lamp or some other furniture item, a coat stand, perhaps, using 3D printing to be able to design connections that are fit for purpose. And you'll see that it evolves. So now we've got effectively 4D printing. So 4D printing and 3D printing, the difference is that 4D printing has a capacity to move or change shape. And so these elements here are able to fold into different shapes. Yes, they're very aesthetically oriented. They might have some functional use of storing things. I thought it was a really cool picture because it included technologies that were 3D printed, and it was timber, so it was fitting for this presentation. But here's where the real advances are. If you look at the powder-coated or coated element on the on the left-hand side there, sorry, and you look at the transformation from one end to the other, you'll see that this organics, this almost a lean process is happening, where they're taking out all of the waste from materials that are not required to be able to provide a fixing that does exactly the same as what the far left picture does, but ends up being the one on the right, which has considerably less material, but it has this really organic shape. And so I think things are starting to evolve in this way. And it's really interesting to see how these things are starting to take on a life form of their own. Here's another version. So this looks like a light fitting or a bracket of some sort that might bolt on the back of a light fitting. If you're familiar with the Lingotto, which is an Igazzini product, you'll notice that might be what this is. But it has this great capacity to be able to transform these connectors using 3D printing and analysis, parametric design, to be able to transform them into something that looks almost organic and living. And again, you'll see now that you can start to take out elements as well by using different cell structures. So this is like a honeycomb cell structure to provide a unique design from an aesthetic perspective, but also very functional, using less material. So it's about saving. And of course, 3D printing extends into sculptural forms. And these are actually timber sculptures. I'm not sure where they are, but these were effectively printed. And you can see that it starts to mimic things like this. This is a picture of Alien Covenant, and you'll see the set here in the background has become very organic. And when I was looking at these pictures several months ago, it reminded me of what's happening with the sets of Aliens. So if you're an Aliens fan, that's for you. But more interestingly, in architecture, it's starting to take hold too. So these organic forms are starting to invade the urban space. This is in Doha. It looks like some sort of a lily or flower. This looks like tree trunks, etc. And then you've obviously got the Gherkin in London, which looks very organic as well. So there's representations of this organics coming through. This was actually a printed sculpture, and it's quite aesthetically pleasing, and it's been lit beautifully, and it's a beautiful time of night. And this is all timber concrete cementitious fluid that was used in the printing parts, and then I think it was inserted into a frame from memory. Parametric design, beautiful segue into this. Essentially, you might be familiar with Rhinoceros or other programs which effectively have a plug and play with Grasshopper, and you put your parameters in and you can start to create these unique designs. The most famous one is the Twisted CLT Tower. It's a beautiful piece of architecture. This is a fairly low-res image. Apologise for that, but there are some really good ones out there if you're interested. And now you start to see things like the Dubai Expo, for example, where these organics and parametric design forms are starting to influence architecture. This is a hardwood CLT structure that was built in the UK. It's American tulip wood, just to show its capacities to span and stiffness, etc. And more beautiful timber sculptures. As you go into parametric design, you see they become more and more complex and aesthetically quite pleasing. And if it wasn't for the parametric design, it would be very difficult to achieve these things. Fantastic summer's day somewhere in Europe. And you've got the beehive. So this is quite a beautiful piece of work using parametric design again, and using what appears to be a ply type wood, and creating these cell structures inside this beautiful dome. More geometrics. And there's the beehive there, the completed version of it. So timber's really moving into that parametric design. It's a very, very versatile a very versatile product timber for parametric work. Robotics. So, of course, using KUKAs and other robotic forms to be able to create sculptures, you can see here that there's a design down the bottom, and what's actually been mimicked is a full-size version of that design. It looks like some sort of woven basket or woven tunnel. Robots are also being used for using bricks. I did hear a claim that robots can lay more bricks than humans now. The reality is I'm not sure how much mortaring they can do, so it's going to be very interesting to see how they fit in those two tasks. And of course in timber manufacturing and assembly, and so there's manufacturing plants quite globally now using robots as a function of their capacity to do glulam or CLT. And of course, robots for assembly. So here's an assembling robot that's put together this particular framing system. Some would argue that it's potentially a piece of artwork, because if that was actually a frame in a house, I don't think I'd be too happy, and nor would you. And of course, now we're seeing robots being used to be able to facilitate the transport of materials within a manufacturing place, to be able to provide chamfered edges or penetrations or noggins and notches and cutouts, etc., that you need to do to put into your structure. And of course, robotics and plant design have led to more advanced manufacturing facilities. I've been very pleased to be involved in one of those recently, and here is an example of how a layout might work from either an OSB or a plywood type plant, using vacuum suction systems, etc., and conveyor tables. Moves us on to Katara. So I've been very, very fortunate. Good friend Nick Milestone gave me some slides to present to you today. So we'd need to thank and acknowledge Nick. So Katara have worked on an engineering, design, material sourcing, manufacturing and construction ethos. So they're trying to create an innovation in the built environment by providing an end-to-end supply chain solution. If you haven't checked out Katara's website, please do go and have a look at it. It's quite a phenomenal story and experience. And of course, they've got 1.2 billion or thereabouts in backing from private equity and banks, etc., to drive the innovation in the construction industry in the they're in the west coast of the US. The Catalyst building is one of the more famous buildings that they've been notarized for. Here you'll see that they had 270 plus panels for this particular building. 7,300 metric tons of CO2 stored in the CLT. A fantastic building. Got a few slides, but before we get there, this is their execution process. So you'll see here that they have their construction documentation. That brings in all your structural, architectural, MEP specs, the contract, 3D files, etc. They park that in that first element. They then get all that information, they start the process, and as you can see there, their 3D model is effectively split out into installation plans, truck loading, assembly plans, piece-by-piece drawings, CNC data, and then that's bill of materials, and then you've got your internal CLT, external CLT, your steel hardware, and your glulam. It moves into various facets of the value chain within inside their own organisation. So you have your piece by piece being fabricated, you have your assembly plans being drawn up, you have your delivery, sequencing, etc., coordinated, you have your installation, and once you've done the installation, you have an inspection and a handover, and they end the process. They find the next mass timber project, and away they go. And the Revit model is something that they use as a foundation base for the way that they develop their buildings, and that's no different for the Catalyst building. And here you can actually see the layout of the building as a typical floor. So you have a center beam there, you've got a couple of beam lines, you've got your panels running acrossways, and you've got the capacity to effectively design in every panel that you need to be able to facilitate the assembly for this particular project. And there's the panelized version or layout. Very much similar as what you saw before, but it's a complete 3D drawing of it. And then you have your modeling as well. And it gives you the capacity to be able to break down the layers and look at discrete elements. So you've got in the green there, you've got your beams running down, and then you've got your cross members running across in the red there. Then you have your floor systems laying in on top of that, and you'll see that on the last model, they've overlaid that with their facade. So they've got a factory in Spokane in Washington State, and 270,000 square feet of mass timber facility. The estimates are around 185,000 cubic meters per annum out of that plant when it's fully operational, running all shifts and has all investment built into it from an efficiency perspective. And there's a couple of shots down there. They're at the bottom of their plant using their equipment. This is their state-of-the-art equipment sequencing. So they go from their timber grading through the planning, through the layout process, through the press and the CNC technology to finish. And then they basically zone it all out. And then they're able to prepare each discrete element within the planning system to be able to be prepared based on the loads they need for the construction sequence on site. And here's just a bit of a video of that. And as you can see, the model layover on top of the actual building meets up quite well. And then you have the final model as it sits at the very, very end. Let me just skip forward to the slide. Oh, there we go. And this is the project that was underway and completed recently. It's quite an amazing project. And you'll see here that the columns are quite large and the beams are quite large. In fact, they pretty much marry up in terms of dimensional size. And this type of unique construction system with everything exposed would probably mimic what Lend-Lease did. They had K-braces and a few other things, but this exposure of the timber has become quite prominent. And you'll see more construction projects and interior photos and some interior photos as well there. So the last project on here is the NTU project. So my good friend Gary Caulfield is the project director on that. I've stolen some pictures from the website because he was a bit cheap and didn't want to give me any. And so you can see here the world's largest mass timber project is the NTU University over there. And you can see some scale models for what it's going to look like when it's completed. And you'll see here that they're actually thinking about using pixels. So there's a bit of testing that needs to go into all of this, but where I mentioned those connectors being hidden, they would potentially look at using these as well because they have a great finish from an aesthetic perspective. That's the Catalyst building that we saw before, and look at the columns and the beams. And here's what the NTU is proposing. So this theme being commonly shared around the world in new timber buildings is quite a fad at the moment. Odds and ends. So just to finish off with very, very quickly, this is clips. This is a structurally insulated cross-laminated timber system. Our good friends at Element 5 in Canada, who've just been awarded a grant for a new CLT plant, have created this clips panel, which effectively solves the problem of I've got one piece of CLT, I want some insulation, what do I do? And typically you would build a stud wall inside that, or you would then batten it out somehow and put your insulation in. They're sandwiching the two ends together and providing you with a structurally insulated CLT system. So watch this space for clips. And the last one here is all of this technology and integration with building and construction is associated with a new Building 4.0 CRC, which I have an indirect involvement with at this point in time. Essentially, the university and a whole lot of partners are getting together some ideas, pure and basic research. I think that there'll be a lot of applied work that will come out of that. The Building CRC4 takes that essential basic or pure basic research into an applied and transformational space, and then it translates the R&D into something that might be pragmatic or useful for industry players. The industry players then provide the application to the end users and commercialize the products or whatever it is, the technology that's coming out of it. Some of the partners are quite extensive. The project just received $28 million Australian government funding for the development, and the centre has effectively started with Matthew Aitchison from Monash being the interim CEO, and Go from Melbourne University. My supervisor there is the research director for the Building 4.0 CRC. If you're interested, go to building4.0.org and you can see more about that. And that is me, and we are, a minute over time. Sorry about that, Alistair. So I'll take some questions now. I'll just get the Q&A panel up. Let me just get this here. All right. I'll just stop sharing that screen. All right, so will the session be recorded and available to watch later? I would suggest it would be, Alistair. Would that be correct? Yeah.
Definitely. It's being recorded at the moment, so it'll be available on the website in the next couple of days.
Yes. Eliza's asked, can I grab the question form, please? Yes, we can do that for you. Jonathan asks, in the industry, been talking about trust at least in the last 40 years since I've been involved. Why is it so hard to get that built into the industry for all? I guess that's the fundamental question about human nature. Do I trust you to do this thing for me, even in contract? And we know contracts don't necessarily always have a level of specific performance. I think that the technology is trying to compensate for our humanness and provide a technology solution for it. So yes, you're right. I think you're spot on with the last 40 years in terms of trust, but hopefully technology will help. What else have we got here? Do we have any recommendation for software that can produce a preliminary 3D project quick and easy? No, it really depends on whether you have a persuasion towards something that's going to be quick and easy, that's going to be useful for some other purpose. If it's only going to be for illustrative purposes, you could use SolidWorks. You could use any type of imagery-based type 3D software. The trick will be, can you transform that into an IFC or some other usable format to be able to be used by designers? Because they want millimeter precision, 0.0 precision. They don't want, a panel floating 10 centimeters above a wall, for example. So it's really personal choice there. ArchiCAD can be integrated, HSB CAD, Global and others. I'm not sure whether it can, but I would suspect it can to some degree using an export from IFC. So I'm hoping that might actually be something that's true, but you'll have to check that out. SoftStick can analyze timber structures within Revit. No export required. Yep, perfect. Thank you. I'll go and have a look at that as well. And it's in the Q&A form if anyone wants to have a look at the spelling of SoftStick. Jim asks, how is fire risk managed in those structures? So there's a number of suppression systems. So there might be internal sprinklered systems. There may be insulated or encapsulated elements of the building. And I think even in the Bergen Treat Tower, they had an external suppression system for fire as well. So I think there was 6 systems involved in that. It really does depend on the type of structure you're building and who your certifying agent is in which country. So I'll leave that question for someone else. Hey, Toby, how are you? What are your views on prefab facade options? What are necessary to achieve time savings? Yes, so there is a couple of prefab systems at the moment that I'm involved with. So FacadeX in Melbourne is doing a couple of prefab systems. They did the La Trobe University CLT building. I found that to be quite an innovative system. They actually produce it not too far from where I'm located. And Monesco are also doing some work there. And I think there's a lot of proprietary systems that are out there. So Toby, I'll have a chat offline in terms of the facade systems and I can give you a hand on that. Adrian asks, how does CLT cost compare to traditional construction? It depends on the total cost of your project. So material for material, it's about line ball at the moment. I doubt it will ever get cheaper. What you've got to consider is building in your program savings and time savings and add back those preliminaries. That's the total cost of the building project that you need to consider. There's also a paper that I've done and partnered with Lawrence Ritchie on, which talks about that. If you're interested, Adrian, grab my details and I'm happy to send it across. David, are standards that govern regulations able to keep up with this rate of innovation? No, they're not, which is why you have a deemed to satisfy when it comes to height restrictions. There was class restrictions and no longer class restrictions, 25 metres for CLT and mass timber and timber framing. But when you go beyond that, you've got performance solutions, and that will be the pathway you will have to go to verify, validate, and authorize your building to go ahead if it's anything outside of those. I'm just flicking through. There's a heap here. I'm just going to jump down a little bit because I'm right at the very top. I'd be interested in a prefab facade discussion. Yep, happy to have a prefab facade discussion. Actually, that might be a good conversation to have Alistair to see whether we can do one on that. Unfortunately, it will be part timber and part something else because the facades are generally not timber. Paul, in reference to CLT presentation you mentioned earlier, is this available? It could be available. I'll have to go and dig it out. Joseph, if you send me an email, I'm happy to have a look at that too. Graham says, where's the technology for waterproofing CLT roofs moving, given the large range of issues involved there in design of potential for failure? Yes, so in the UK, they have a very difficult time trying to pressure impregnate their spruce with pre-treatments, with termicides and fungicide treatments. In Australia, using a product like XLAM would promote, we have the capacity to fully pressure impregnate the timber. So you can get H3 certified panels that have all the feedstock fully pressure impregnated, and you're able to use that as a preventative measure. On top of that, the design needs to be correct. It needs to effectively be a swimming pool tanking type approach to it on a roof, for example, if it's going to be some sort of a flat roof. We would advise not putting swimming pools on top. I've been involved in 2 conversations where people have said, can we put a swimming pool on the top of that CLT building? No, the dangers are too risky. So the Australian standards doesn't necessarily call for it, but people like XLAM and others do a treated product in the wet areas, and that's put in place for a preventative system. In New Zealand, it's actually a standard treatment for all panels and the preventative system for bathroom and wet areas to mitigate their leaky building syndrome. So happy to have a chat offline for either of those if you want. Callum asks, can you get your thoughts on cost comparisons? I've spoken about that one. I'm just darting around here, just drop down the bottom. What standards govern CLT? They're in the Australian standards. You can actually go and have a look at those. Adrian, if you give me a buzz offline, I'll help you out with that. I need to know if you are in Australia first and foremost, and if so, I can help you out with that. Any future involving bamboo? Yes, bamboo is gaining more and more prominence. My supervisor at Deakin University, Mahmood, is in touch with Nanjing University. There's a great relationship between Deakin and Nanjing, and they have been doing a lot of work on the bamboo development, which is really starting to get some prominence because it grows at an exceptional rate. It has exceptional strength characteristics and can certainly be put into a building structure that provides utility. I guess that the bit that's really important is the transformation of the material, the adhesive, the pressing technology, and then the performance based as a commercially viable and available structural technology. So there's a little bit more to do there. Is there a role for thermally modified pine? Yes, there is. In fact, when we were in Nelson in New Zealand back in 2017, where we had our second plant and I was working at XLAM, we created a Bodo wood, thermally modified wood fence. And I'm pleased to say that after many years, it's actually still standing and it still looks great. In fact, the ivy loves it and has started to grow all over it. But yes, you could do that. I'm not sure how much the thermal modification process changes the strength characteristics of the timber. I did some pressure impregnation treatment with fire retardant, which was using LVL. And we had an LVL 15, so 15,300 modulus for elasticity or stiffness calibration. And when we put it into the pressure tanks, it came out the other end, it was actually only 13,200. So it dropped this quantum in terms of its capacity for stiffness. So we would need to know what the thermal modification process does from a structural perspective, but we should be able to use it at least for the outer layers from a durability perspective. So that might actually work out quite well. How many CLT suppliers are there in Australia? There is one established manufacturer, which is XLAM, which has a plant in Albury, Wodonga, and the team's pretty much around the country. You have a secondary plant in Western Australia, which is in a sort of a proving or a testing phase. They haven't necessarily produced anything commercial that I'm aware of. And you have a hardwood and hybrid manufacturer now in Tasmania called CLTP. And they're about to launch a eucalyptus nitens, which is effectively a hardwood because it's designation from a species perspective, but it's probably about 100 kilos, 150 kilos per cubic metre in density more than the pine. So it sort of sits in that bridging gap from a density perspective, but I believe they're actually almost available, or they're already available to produce material. But CLTP used to be called Burnie. It's just called CLTP Tasmania if you're interested in that.
Paul, just on that also, there was a question earlier whether anyone else was exploring hardwoods outside of Europe, and certainly we see hardwood used in a number of glulam manufacturers here in Australia, and Australian Sustainable Hardwoods have got their new Masslam product that they're using for mass timber elements for beams and columns.
Yeah, and thanks, Paulo. The other additive to that is that there's between 5 and 6 different importers of material for CLT as well. So if you don't get it locally, you can get it internationally as well.
Joe asked a question earlier on, Paul, about is Katara using commercial software like HSB CAD or their own design automation tools?
I think they're using a mix of both. They've been developing their own platforms, but they also would be using things like Global or something else to do their RFEM. So I think they're sort of in that space doing both. Certainly the model before, I think, was a proprietary software for someone else, but they are developing their software. I'd have to ask Nick Milestone when I speak to him next, so I'll follow up if anyone's interested in that.
There's also a question about your thoughts on seeing CLT in the residential space.
Yes, so interesting that is mentioned, because we now have in Australia a residential Green Star program, and there is points awarded for timber in the commercial Green Star program, so I think it would be available. Typically using CLT in a residential sense, that is a detached single dwelling, is quite expensive. And if you look at what you would get from the Metricons, the Simmons, the Henleys, etc. of the world, it's very, very difficult to compete on a square metre finished price for them versus the superstructure alone for the domestic house with pure CLT. But if you're looking at townhouses, or you're looking at a row of units, etc., that were going 2 or 3 story high, yes, it starts to become more viable. So it depends on the densification and the massing that you've got for your buildings, and then you're able to provide a utility through having CLT technology. My good friend Alan's online from, I think he's in Brazil today. I'm not sure whether he's in the lockdown or not, but he says, how do you deal with clients wanting to show the structural the timber structure outside of the building with no cladding? You don't. It's too big a risk unless you can come up with a timber cladding which sits on top of a membrane that is watertight. Then it's effectively a false cladding. I think that's the only way, and it would be really the way to go forward. But Paulo said there, contact us for advice on a project. I think he's in international for. If you actually go on LinkedIn, you'll see he posts probably more posts than me. I think he's up to about 80 posts a month. So I'm doing 50 or 60.
Paul, I think we might have to call it a stop there, but you've done a fantastic presentation as always, and answered those questions admirably. So we really thank you very much for your great effort today, and we'll all clap you online for a extraordinary performance. So thanks once again for everyone also. We've got next week a presentation on designing for durability. So again, next Wednesday at 23rd of June at 11 a.m. with Professor Jeff Morell providing that presentation. So thanks once again to everyone for joining us today. And Paul, thank you.
Thank you.
And we'll see you all online in a week.
Have a good afternoon or evening. Cheers. See everyone.